20 years ago, 10 years ago, the internet was mainly used for email and the World Wide Web. You can see this very nicely on this graph from Cache Logic that shows basically the percentage of internet traffic categorized in different applications between 1993 and 2006. But the fact that web and email used to be the killer applications nowadays is no longer valid. So nowadays what we have basically 70% peer-to-peer traffic. This changes the rule of the games very much because peer-to-peer traffic is behaving totally different than the traditional web and email traffic. Peer-to-peer applications like BitTorrent, Skype, and so on, they are creating overlays on top of the internet that dynamically change and that especially are outside of the ISPs, the internet service providers' control. And this is a challenge for managing this type of traffic. Today's ISPs, they have means to manage the traditional traffic, the conventional traffic, that is the traffic that we had maybe 5 to 10 years ago. But these techniques are not so much applicable to peer-to-peer traffic and potentially future applications that may arise. In Smooth IT, we have come up with this scenario of a number of different autonomous systems, internet service providers that are interconnected either via peering agreements or via transit links that they have to pay for. Now, peer-to-peer overlays who are not aware of locality, who are not aware of the underlying network, of course, arbitrarily use these links by connecting to certain peers that either have a certain file or that are providing a certain stream of video or audio data. This is of course what generates a bit headache for internet service providers because of course they have a big interest that those peers are using mainly peering links which come at no cost for them rather than the expensive transit link. There are things like applications doing zigzag routes over the Atlantic all the time, and this is a big problem for internet service providers. So our objectives are to manage these overlay networks through collaboration between all the different parties involved, including the overlay providers, like for instance the Skype, but also including the network providers, network operators, and of course the end users who are installing these applications on their machines. And our goal is to optimize the traffic. On one hand, the incentive that we are trying to create for the operators to participate in this game is to allow him to recover the costs and the investments that he made into the technology. On the other hand, we are also trying to give the overlay providers incentives to participate and allow them to take an active role into the overlay in order to be able to increase the quality of their services and thereby also increase the users that are using their services from which they may potentially get advertisements. And last but not least, of course, we are also trying to take the user into account, who of course also is interested in the best possible service quality, which can either come in terms of reliability of the services, round-trip time, for instance, very important for gaming, peer-to-peer gaming applications, but last but not least, of course, bandwidth. That's always the biggest issue. How long does it take until I can download a certain file? This objective, of course, comes with certain challenges that we are addressing in our project. On one hand, what we need to do is we need to integrate and map these diverse requirements that operators on one hand and overlay service providers and users on the other hand have. And this is not easy to do. We need to be able to define the right economic and technical signals that allow these different parties to communicate in a trustworthy and in a reliable way. And we do not want to focus only on a single provider. The internet is a cloud of multiple providers that are acting autonomously, a multi-domain environment, so we need to take this into account. And the internet is growing, the internet is not static. So it is very important, and it is certainly the last thing we want to do, to place somewhere a central server that takes care of all this. No, that's not the solution. The solution that we are envisioning is a scalable solution, an efficient solution that can be operated autonomously in the different autonomous systems that are existing, thereby maximizing the benefits of not only the operators but also the service providers and the users in terms of their utility. There are several ways how you can address these challenges. First of all, what you can do, and what already has been done in the past, is you can try to find an agreement. So for instance, Skype, they have agreements with operators. This can happen in file sharing cases, for instance, through active caching of content, where operators place certain local caches for particular overlay applications in their networks. A totally different approach is to try to promote the locality, the information about the topology of the underlay of the network, in order to allow the users and the service providers to improve the service quality. Because a fast link that goes over a peering link is not only better for the operators in terms of cost, but it's also better, most likely for the user, because it's faster, it has a higher bandwidth. And then of course there is also the possibility to differentiate the traffic, to differentiate web traffic from peer-to-peer traffic, and also this has been done in the past, and it's getting more and more difficult to do this because of course peer-to-peer users, peer-to-peer applications providers are more and more often encrypting their traffic, not allowing operators to label this traffic and to do things like deep packet inspection. So it's getting more and more difficult, and it's probably not a viable solution for the future. Showing here the example of locality awareness, what SmoothIt aims to do is to place a box which we call SmoothIt Information Service in all of the autonomous systems that is collecting information about the network, which is most often information that only the operator has, and offering this via a standardized interface to the overlay to the end users, allowing them to take advantage of peers that are, for instance, located in the same autonomous system, and thereby having a much higher performance and having a much lower cost for the network operator. So basically what this SmoothIt information service does, it takes a list of candidates from the service provider or from the overlay, and it gives them a priority. It says peer 1, peer 2 and peer 3 are for me the best one because they are in my own network. Peer 4 is still okay because I have a peering agreement, but please don't go to peer 7, peer 8 and peer 9 if you don't have to, because this will generate costs for us. So that's the idea, and that's where we are at the moment.